Um, so I already gave a short introduction about Gap and Prosper. And these most probably are going to be the tools if you go to Statoil or if you go to any big oil company here in Europe or in Norway. Probably you will use these tools from petroleum experts. And the idea I have given you, it's already on its learning on the class, on the folder for today's class. So that's the task that I designed for these 2 hours. But I think maybe to give you some orientation where you can find everything, so you just to get you started. But then the idea is that you work on these tasks by yourself. Then we take a kind of a break, or we take kind of a summary after Prosper. And then we go to the Gap part. We do again an introduction, and then we do again another just reviewing the results. Okay? And I will be just walking around helping you if you have some issues. So let's see. All of you should have opened this interface of Prosper. Yeah? No? Maybe you don't have license because they're all already 10. 10 out of 10. Yeah. So you have to sit with someone else. Okay, so that's the main window of Prosper. You just get and is divided in 6 parts. Okay, so this part is for general information, general setup, where you're going to see, for example, some things like which kind of fluids you're going to use, what kind of well is it, does it have artificial lift or not, okay, does it have different, is multi-branch or multi-layer in this general setup. And you will see for our case it's fairly simple. We can try just to open what kind of options do you have. If it's black oil, how many stages do you have, if you have any emulsions. Okay, this is the emulsion curve that I showed you in class. Which water viscosity, how do we calculate it, if it's a Newtonian or non-Newtonian fluid, if it's flowing through the annulus or if it's flowing through the tubing. So these are things that are quite straightforward and more or less self-descriptive. Okay, then we go to the part on the center. Actually here you're going to say what is going to be the PVT model that you're going to use, and there are basically only 2 choices. It's EOS or BO. Okay, and BO can be either with tables or with correlations. Then on this part you gave information about the inflow. You give information about the inflow, and there are many models. You know, we have been working in class just with the gas and with liquid, but there are actually many other models. I guess you covered them in production wells, I think, those of you who took it. But there are many models, and depending on the type of well, the type of fluid, if it's horizontal, deviated, you have here many models, and you have to go to the manual to see actually which one applies for your case. Oh, here's something that I forgot, is that you can match the correlation if you have some data measured. Okay, you can also input here. So let's see that dialog for some time. Yeah, maybe you, after I use it, I can close it and then you guys can use on your computer. Okay, and it doesn't want to open. Yeah, maybe I have to click done here. Okay, and you have some basic information like which correlation are you going to use, some properties of the fluid, that is the minimum that the black oil needs to run. Okay, then you have also here, if you see at the top, you have a match facility that allows you, if you have any data measured from the lab or from any experiment, that you can use and tune. Remember that these black oil correlations have a lot of tuning parameters. Okay, so in that case you will be tuning those to match the data. Okay, and here that's just your match data. and matching. I think one of them actually you put the table in table format for different pressures and temperatures that you have these values, and in matching you actually do the solver. Okay, actually you do the tuning of the parameters.
How do you open the division
What?
window?
You have to first, because to start a model you have to click here done. Okay, after you input all the information, when you click done, all the others they become active to introduce information. Okay, then PI, yeah, errors, we have to give that. Okay, so I'm not going to go in details into these two, just mention them. Here you get Inflow, you have a lot of options. Okay, and something that is very important here is that you have to click calculate, because the way it uses the IPR is not the equation, but it's on a table. Okay, so you have to generate the table of bottom hole pressures and rates. So remember to press calculate after you are finished inputting the data. Yeah, and you will see, then you can inspect the shape of the IPR to see just if it makes sense. And the different applicability of the models, you can go, they have it in the manual, they give a brief description, or you can also go to the paper where they refer to. So you can also go and search what the author was using and if it's valid for your particular case or not. Here you have also, if you have some points that you tested the well, okay, let's say you have a bottom hole gauge, pressure gauge, and you measure how much rate was coming out at that point, so you can tune IPR constant to test data. And that's something that is used quite often. We initially assume an analytical model, a formula, an equation, and then when we have measurements, we try to tune, or we try to modify slightly the constants so it will represent exactly our measured behavior. Then equipment, here is where you have to include the layout of the well. You have to include also the thermal conditions. Okay, you have to include also the heat capacity of the fluids. And in this case, you will see just in a moment, we are going to do it very simple, just a vertical well with no deviation, but you can actually do very complex configurations. And here is where we have the analysis that we make if we want to take only the IPR, only the tubing, if we want to take the system, if we want to do sensitivity, what will happen if I change the water cut, and also most important, so here we have IPR, we have tubing, we have of the system, that this is our hydraulic equilibrium. Okay, they have different names, okay, so you have to be aware exactly what it means. You have another one that is gradient, that is exactly to see what happens in the tubing. When you want to see more details, what flow patterns, what superficial velocities you have, you go to gradient. And then you have sensitivity, that you want to see what happens with sensitivity, what happens with the tubing tables when any condition changes. And last you have tubing generation of tubing tables, okay? And this is just information about the license. So the problem that you have to set up, I hope I did it quite straightforward. So you just have to get used a bit to the interface. Where is it? Here? Yeah. Here you have all the properties of the fluid. Okay, 30 API is producing GR is 142. Is that low or high? Is that a normal oil? Is that a heavy, slightly heavy oil? Is that a... That will be homework, I guess. Then gas gravity.
What is the equivalent value in SCR?
In the?
The field units?
Oh, the units, to change them.
No, what is the equivalent value in field units?
Yeah, someone that's quick with the computer has to do it. You have it in field units, your reference. Yeah. Okay, so here it says which correlation to use. Okay, no H2S, CO2, and nitrogen, and the deviation survey. That's the layout of the well. And geothermal gradient, very simple, from 0 to 100 degrees Celsius. Then you have the layout of the well to see which equipment do you have. First you have flow in the casing, not too much for 80 meters. And then you have flow in the tubing. Then you have the downhole safety valve. And then you have flow all the way to the wellhead. Okay? And you have more information about the reservoir. So your tasks now for this first session or this first hour is to set up the Prosper model, to build it, okay? Just like we do it in Excel. Then you have to calculate the bubble point pressure at reservoir temperature to see how much it is, okay? Just to have like a reference. Then you have to estimate the producing rate, assuming that the wellhead pressure is 100 bar. That number, we don't know still where it comes from. Somebody said, that well, you can assume that it operates at 100 bar constant. Okay. And then you get a question that it says, is it correct to assume a linear PI? Because that's what we are using. And then you have to generate and export the lift curves to be used in GAP. Okay, because the second part is going to be actually to build the model. Not only one well, but of the whole system. And I'm giving you already a help. I'm giving you the ranges that you have to put for wellhead pressure, for GOR, and for water cut. That clear? Yeah? Any question? So I'm going to be just walking around just to help you if you need any help. And if there is any question that is common, I'm going to take just to discuss it here. Okay? So I'm going to now to release this license. Okay, some people were asking what happens if you have a well that you produce from two different formations, okay? Or you have a multi-layer or multi-branch well. In that case, in this window, you have an option that says inflow type multilateral well, for example, that you're producing from different formations. Okay, when you activate that, you will get a whole bunch of other options that you can fill, and yeah, you're going to get a lot of fun. Then on this part on the PVT, people were asking how to calculate PVT properties. So you click here up, very obvious, calculate. Okay, and here you can use automatic. It means that you give the lower and the upper bound, and it generates depending on the number of points in between. Okay, or you can just say user select, and I say, for example, at reservoir conditions 100 and 360. Okay, and then I click calculate, and then appears this window with all the results at that pressure and temperature. And what we are interested is the bubble point pressure at that temperature, 289. Okay, bar. Then what else is worth saying here? Then on the IPR, yeah, what I was telling you here on test data, you can actually put one, for example, if you measure in the field, you have a downhole gauge, or you have a gauge that measures the flowing bottom hole pressure. You have to get used to these abbreviations. So you just put the value here, and you try to, okay. Then you can try, it will try, I think, try to change this 12 to try to match the data that you input here, I think. And you can enable the points or enable the points. Then, okay, but you have to click calculate to generate the plot. Otherwise, if you input only the values, it won't make the plot. Then here, surface equipment. This was done originally because we didn't have much networks, or we didn't have much ways, we didn't have gap. So if you want to put here, for example, a pipeline, a compressor, and you put a separator, you could do it here originally. But now that you have gap, usually this is not very much used, okay? This surface equipment. Downhole equipment, you put the information about the layout of the well, and something that is important is that you have to give the depth of the section, of that section. You cannot give just relative increments, but you have to give the depth of each section. So if we, on the layout of the well, this is going to be 120, this is going to be 120 plus 2 for 40, and this is going to be the sum of the three of them. Okay, just like you do in reservoir, you do in any of the other disciplines. The SSB is important because it's a restriction, okay? As you saw on the lab, it's actually a smaller diameter path that also creates an additional pressure drop. The heat capacity, even if it sounds a bit strange, that is should be part of the properties, is actually here, because that's actually when you use it for the thermal calculations. Okay, and usually you use the values by default, but you should approximate them somehow. Then inflow is more or less the same window that we had here, okay? But in system, we actually do the equilibrium, okay? We had available and required, and we do the equilibrium depending on the point that we select, okay? In this case, the solution node is the bottom node. That means that it's going to calculate co-current, the pressure, all the way to the flowing bottom hole, okay? So to the bottom hole. And from the wellhead, from the top node, all the way down to also to the bottom hole. And it's going to make the intersection there. You can also change it, and you can say I want to have it at the top node, which in my case is the wellhead, and then in that case it will calculate co-current all the way to the wellhead, and counter current, you know, in our case will be just constant, okay? I'm not sure if you remember in class that we had one curve like that and just a constant value, okay? This is the equivalent. And the intersection point, you can see it here to the right. Maybe it might be slightly different. I think this file is slightly different, but it's around 1,100 standard cubic meter per day. All of you got it? More or less?
97.
Okay, fair enough. And here here it also gives you some options about which correlation you want to use. And Petroleum Experts is a mix between correlations and also has some mechanistic models. But they have some other options. You go to the manual and you see the description of each one of them, what it represents. Yeah, what else? Okay, gradient. This is, I told you, to see what happens along the tubing, what kind of flow patterns you have, where do you have most of the pressure drop in the well, what kind of superficial velocities you have, if you are afraid that you might have erosion, etc. So here you have to do a bit manual. You have to put the first node pressure that was 100 bar, the water cut that was 0, and then the liquid rate that was 1100, okay? And then you click calculate, and this is an option show. It's just going to show you as it goes calculating, it just displays the values, or just hide and it does the calculation and then it plots the table. So here is where I told you that you can get more details in what's happening in the well, which kind of flow patterns you have. In this case we have bubble and then slug, and yeah, you can see how the pressure and temperature change in the tubing. Okay, that's kind of in detail analysis. And then after that, I'm not going to go into all of this, but just these three, which are the most used. Then you have VLP, vertical lift performance. That's actually to see how the required curve changes with different characteristics. So if we put here 100 and the water cut 0, okay, and calculate, okay, it's just going to show the same plot that it had before. Okay, the required curve at the bottom hole, and you can also okay, to see what happens with if it changes. I go here to cases. Let's say that at a later stage in the life of the well, then the water cut changes. For some reason, there comes an aquifer that begins to produce water. So we are going to say water cut, and let's say initially it was 0, but then it changes all the way to 50, okay? And then you say, for example, that the GOR due to gas coning is also going to increase from the solution to, let's say, 500, for example. And this is where I told you that it's crucial to use an adequate number of points, okay? Because later we are going to do interpolation in these tables. So if you use only 2 points, it's going just to do a linear interpolation between them, and the behavior might not be linear. So it's important that you take enough points. 500, And then we have the, of course, we are not sure about the top node pressure. We are putting 100, but now when we put it in the network, it might have different pressures. Okay, depend actually on the back pressure of the network on the well. So here we are not really sure. So to be on the safe side, we could put between separator pressure, which is 35, and we can put all the way to, I don't know, 50, 75, all the way to 150. Okay, for example. The upper limit, of course, comes given by the reservoir pressure. Okay, you can put it, if you want, all the way to 300. And now you have input that, and then you click calculate. Okay, and it's going to calculate for every combination, for all of these big matrix that you gave, all the tubing curves. It's still taking some time. Okay, and then you can select any case to see what happens. That's with top node pressure 35. That's with 50. Of course, it's going to be all the time. Okay, how it should go with if we reduce the tubing, the wellhead pressure. Just to see if you remember still from the first part of the course. Okay, if we have our flowing bottom hole pressure versus rate, and we have, this is for a fixed wellhead pressure, 1. If we have for a wellhead pressure that is less, how it looks like? Is it going to be like this? Or is it going to be like this? Okay. If I reduce the wellhead pressure, I'm going to get more rate. Okay. So it should be this one. PWH2 is less than PWH1. And here we put PWH0. Okay. When you have more water, you have more losses. Okay. When you have more gas, then you have less losses, etc. But then after we have calculated all of that, we can use them to inspect the sensitivity. Okay. But also we can use them to do our calculations in GAP, for example. So in that case, you click here export, and you want to export to GAP, which should be someplace here. Okay. Continue, and it generates the BLP, the TPD file to use in GAP. Okay? Any questions, comments, other issues that you had that I didn't mention? So how are you doing? Are you, all of you are finished, more or less? Yeah? Did you generate the table already? Huh? Yes? Okay. Enough number of points in between? Yeah, good range of reservoir, wellhead pressure and water cut. Yeah? Okay. So we change now to GAP? Yeah? All of you agree? Yeah? Okay. Okay, in GAP, let's open GAP. You have to click new, and then you have to save it, of course. And the case that we are going to make now is really, this well was not isolated. Okay, it was a subsea well. The second part, the second exercise, it was not isolated, but it's part of a production network. And this is very simple. It's just 3 wells that are producing to a riser, a separate line. And here the riser is not drawn. Okay, you have to draw it yourself, or you have to be sure. Here, this is the seabed, and then you have a riser that goes up to this separator. Okay. And the water depth is 300 meters. The separator is 30 meters above the sea level. That's the height of where the platform, in this case, is an FPSO. And the riser, because it has this shape, an S riser, it's the length is 700 meters. So you have here all the dimensions: 5 kilometers, the inner diameter of the pipes, and then a big section of 7 inch, 12 kilometers. And then you have this riser, okay? That you just take it into account that you have to put it.
What is the length of the line from well 1 to the gathering point?
This you can assume that they are in a template, okay? They are very close. The wellhead pressure is the same for both, okay? This junction, this distance can be neglected, okay?
Sir,
Yes?
the riser starts before the separator?
Yeah, let's put maybe better to... How is it? Well 1, well 2, and well 3? Like that? Sorry. Okay, so this is 5 kilometers of 5-inch. This is 2 kilometers of 5-inch. And then you have this horizontal flow line, 14 kilometers, 7-inch. And here you have a riser that goes up and ends up in the separator. And the distance between the seabed and the separator is 330 meters. And the total length of the pipe, L, is 700 meters. Okay? Yes? Okay, now in gap, so you will think initially that you need to generate that table for each well, okay? That you have to repeat the same for each well. That will be one way to do it. You just go duplicate this file. By the way, do you remember what was the... Why do we have so many files? How many Prosper files do we have? Okay, we have TPD, which is the tubing. I think I put this already, but let's... Okay, so this is the out file, that's the main output, or the main file, Prosper file. This file has almost every information. Okay, this TPD was generated when exporting BLP and has the information that we need to bring in GAP, to import in GAP. Then this ANL is the analysis file, and that's saving the information actually that you put here. Only everything that you introduce in this screen, the analysis screen, that's saving that information. Then you have VLP, that's a gap, that's used by gap. This is gap. This SYN is just the whole simulation. That's the one that we actually open to access the interface. To open the file, simulation interface with F. Okay, and PVT, the one that has the fluid properties. So if you want to duplicate the file, you have to just take this out, okay? Change the name, put well, this will be, for example, well 1, I think. Because all wells have more or less the same layout, so just to make it simple for you. But they have different GOR, water cut, and PI. Okay? So you could just duplicate and change, what is different in each well, and then generate a new TPD. Okay, you can do it that way, or I will show you now how to do it some other way. So for wells, okay. Now we go to gap and we have to build okay, this one is nice because it's graphical. So you have to build a network here. What is your arrangement of wells? So first, if you see here at the top, you have, first let's go and change the units. We want to use Norwegian SI. They are by default. And here you have all kind of equipments that you can put in your, that you can use to draw the system. Okay, separator, junction, pipe, well. So we are going to take well. Okay, every time you click, that's something, be careful. Every time you click and you try now to click here on the canvas, it's going to put one well. Okay, that's nice. But if now you continue clicking, it's going to put wells, wells, and wells. Okay, so be careful. So in that case, if you don't want to put any other well, you go here to the right and you just click again select, and it's going to change to the mouse. But you have to get used to this way of working. Okay, you click here, you put your element, and then you click back and you click on the mouse, right? If you're selecting something, it has a blue circle around. If you want to unselect it, you click here, unselect. Okay, so you want to try yourself first, yeah, with the yeah. One thing, when you put the well, you have to link the Prosper file, okay, and you have to link here in VLP the TPD file. Okay, you have to click import and link this TPD file. But then there is one more step that you have to click here, generate well IPRs, to be able to transfer the information from the Prosper file to GAP. Okay, and you have to do the same with the VLPs. Okay, be careful of that. And then the rest is just putting joints, okay, and putting pipes, etc. You want to try you first a bit? Yeah? Okay.